All right, time for our final video of our oblique triangles unit. Today we're going to be talking about the area of oblique triangles. Now the area of a regular triangle is 1/2 base times height, but that really requires that the base and height be perpendicular to each other, and sometimes it's just not convenient to find that. All right, but using trigonometry, you can use the k equals 1/2 AB sine C for the area. The area K is going to be 1/2 side A, all right, times side B times the sine of angle C. And listen, folks, the really important note here, again, just like before with the law of the cosines, the letters don't matter. The letters do not matter. Use any two sides with their included angle. Okay, so if I know side BC and angle A, I can still find the area. I can do 1/2 BC times sine of A. All right, let's get started on our examples here. Triangle ABC. All right, well, triangle ABC. Again, not concerned about drawing this to scale. Just want to have a triangle with A, B, and C on it. What's important is that you label little a across from angle A here, right? And little b across from angle B there. So that's 12. Side B is 12. And they tell me that the sine of C is, the sine of C equals 0.5. All right. So there you go. I have the information I need. I have two sides and the angle between them. It says find the area. All right. Well, K equals 1/2 AB sine C. All right. And the area K is going to be 1/2 A, which is 16, B, which is 12, and sine of C, which is absolutely not the sine of 0.5. It is just 0.5, okay? The whole sine of C here is 0.5, all right? Don't do the sine of 0.5. That would be incorrect. And then I just need to multiply from there. Look, I can do 1/2 of 16 and 0.5 of 12. That's basically half of each of those. So 1/2 of 16 is 8, and 1/2 of 12 is 6. And I've got K equals 6 times 8 is 48. There we go. And there are no units here, but it would be square units if there were. So I have 48 square units. This time, I'm giving you the area of triangle DEF. I'm telling you it is 101 square centimeters. Little d is 16, and little d is 14. Find f to the nearest tenth of a degree. And notice that that's a capital F. That's an angle, okay? So, triangle DEF. Don't care what it looks like. Just make sure you label D, E, and F. All right? Little d is 16. Little e is 14. So, they want me to find capital F. All right? Well, that's going to be this. All right? Which is I have two sides and the angle between them. Two sides and the angle between them is what we're talking about. That's going to fit in nicely with my area formula. 1/2 AB sine C. Notice there's not even an A, B, or C here, right? It doesn't matter. It's 1/2 times one side times the other side times the sine of the angle between them. And that's F. All right? Well, listen, I can't have two unknowns here. But fortunately, the area here is 101, so that's what K is. There we go. All right. So I'm going to have 1/2 of 14 times 6. Well, 1/2 of 14 is 7 times 16. Sorry. 7 times 16, and I get 112. So I have 112 sine F equal to 101. Now, I hope at this point you've gotten used to what you should do here. I mean, I'm trying to get F, so I'll isolate the trig function first, right? Here I can divide both sides by 112, and it's really not even necessary to divide that, or reduce it for that matter. I have sine F equals 101 over 112. And then, therefore, my alpha, or my first F, right, the one in the first quadrant will be this. All right, so I've got second sine 101 divided by 112. And I get 64. It says to the nearest, find f to the nearest, there we go, tenth of a degree. So if I'm finding f to the nearest tenth of a degree, my f is actually going to be, should have written that down, 64 degrees, 64.4 degrees. 64.4 degrees. And you can see my note here. Since sine is positive at both 1 and 2, I have another possibility, right? I could also have f equal to 180 minus 64.4, all right? And that's going to give me 180 minus 64.4 is 115.6. Well, that is 115.6 degrees. And those are the two possible angles, two possible values of f. All right? And I need to kind of keep both of those, right? All right, I'm going to keep both of those. Obviously, if I have 115.6, then f would be the longest side of the triangle. Otherwise, it's probably something else. Okay. So now I need to find the area of the triangle to the nearest tenth. Find the area of the triangle to the nearest tenth. Oh. That's pretty easy, isn't it? I think it's, I've got two sides and the angle between them. So it's k equals 1/2 AB sine c. Well, not even a letter on the diagram, but I understand that the little a and little b are representing two sides, and sine of c, that's the angle between them. That's really what's important here. Then I have 13.2 times 13.2, so that's like 13.2 squared. Sine 43 degrees. And that's going to be my k. And that's just a simple evaluate. Don't forget to evaluate it, right? I'm not done. I can evaluate that. I'll use 0.5 for a half. And then times 13.2 squared times sine 43. And you don't have to hit the times before you hit sine of 43. If there's no operation there, it will multiply it. All right, so to the nearest tenth, I have 59.4 degrees. 59.4, sorry, is my area. I started to say degrees, but it's not. It's not an angle. It's an area. And it's square units. Right? This one doesn't happen to have units. If I had said this was 13.2 feet and 13.2 feet, if I had said these were in feet, then that would be feet. This would be feet squared. But it doesn't say that. All right. So the last thing I have is in parallelogram math. MA is 16.7, AT is 20.1, and angle A measures 108.3. All right, so for A, find the length of MT to the nearest tenth of a centimeter, and then B, find the area of MAT to the nearest hundredth of a square centimeter. So let's not get too far ahead of ourselves, right? We'll draw parallelogram math. M-A-T-H. I can get rid of these things. These are from an old assignment. It's not your assignment. We're doing things in class now. All right, so parallelogram math. Okay, there's a parallelogram. M-A-T-H. It tells me MA is 16.7. Uh-oh, not drawn to scale alert, right? AT is 20.1. That's that side. I probably should have drawn that a little bit more towards the middle of that. All right, a lot of kids have a tendency to draw it right down here next to the corner, and it's confusing whether you're referring to the angle or the side. So make it clear. An angle A measures 108.3. All right, well, hey, that looks like an obtuse angle, so at least I got that part right. It doesn't really matter here. What is important is that you recognize the fact that a parallelogram is really two congruent triangles, right? You got side, angle, side, and side. You have side, angle, side, and then this is side, angle, side here as well, 108.3, right? So you have side, angle, side congruence. So really, if I could find the area of one of the triangles and double it, I could find the area of a parallelogram. Or, instead of doing the half, right, I can just do K equals AB sine C. I don't need the half for this parallelogram here. So I have two consecutive sides of the parallelogram and the angle between them. Don't do the half and you'll get an area of a parallelogram. Okay, so the K is 16.7 times 20.1 times the sine of 108.3 degrees. And that's just something that you can just put right in the calculator and evaluate. 16.7 times 20.1 times the sine of 108.3. All right, enter. And I get K equals 318.69. 69. There we go. Oh, you know what, guys? I got so far ahead of myself, I forgot to read the directions. So what have I actually just done here? I did B, right? I did B. I found the area of math to the nearest hundredth. Right? Make sure I rounded that hundredth place correctly. Sure. Okay. So that's actually B, right? It's important to read directions, but if you don't there, right, you just kind of, after you finish working, you know, you take a breath and see, okay, did I answer the question that was asked? And that's what I did there. So I was able to recognize, oh, I did B already. Now I have to do A. Find the length of MT. Oh, the length of MT. All right, this harkens back to something we were doing earlier. If I have a side, an angle and a side, and I want to find another side here, this angle, right across from that angle will be our friend, the loneliest side, and I can use the law of cosines. X squared equals 16.7 squared plus 20.1 squared minus 2 times 16.7 times 20.1 times the cosine of 108.3 degrees. And that's one of those big, long things that I can kind of evaluate all at once. 16.7 squared plus 20.1 squared minus 2 times 16.7 times 20.1 cosine 108.3. All right, enter. And I am getting 893.695. So 893.69, I will say 6. Get that rounds to the 6 there. And I got x squared equal to that. And take the square root of both sides. And really, you could even just kind of put that in and then hit second square root of my answer from before, and I get to the nearest 10th. Okay, nearest 10th, I get 29.9. All right, so x equals 29.9. All right, so I've got an answer. Let's just reread real quick and make sure. Nearest 10th of a centimeter, 29.9 centimeters. Okay, that'll do it for the area. All right, the area notes for this is done. All right, well, good luck, and we'll practice force and area problems together tomorrow. Thanks, bye.